Hello everyone. In this video we are going to talk about force, what a force is. So a force is any kind of push or pull acting upon an object. Um, and a force is a vector quantity, meaning it has both direction and magnitude. And also the SI unit of um, force is Newton. It means um, force is measured in Newton. Well, basically, there are two main types of forces: contact forces and field forces. So let's begin with looking at some examples of contact forces. Well, contact forces are those forces which occur when two objects come to contact with each other. And examples include when you push a car. For example, you come to contact with a car, so therefore you can push a car. Or when you kick a ball, so again you come contact with the ball. And the other example is when the engine of the train acts a force upon the train to make it move. And so these kinds of forces are called contact forces, which are very, very familiar with. But the other type, which is field forces, are those which occur even if there is a distance between two objects. So, in this case, two objects do not necessarily need to come to contact. They can even be away from each other, and there is still a force acting upon each other. We can say, like magnetic forces. When a force uh, occurs between two magnetic poles, like poles or unlike poles, for example, or an electric force which occurs between two electric charges. And the last example is gravitational force, which is acted upon any objects around us from the ground. And this is also another example of field force. We will be looking at some forces in this video, for example, weight, tension, normal force, friction force, or frictional force, and we will talk about balanced and unbalanced forces. So, what is weight? What is the weight? Or well, weight is the gravitational force acting upon any objects around us, and it also has direction and magnitude, both direction and magnitude. And the direction of this weight or gravitational force, just another name, is always towards down, towards the center of the earth. So no matter where we are, just the direction of the force acting upon us or anything around us is towards the center of the earth. Um, this gravitational force uh, is different from planet to planet. For example, on the Earth, the gravitational force is different from that of on the Moon or on the Mars or other planets, and the reason is because Um, the planets have different um, acceleration due to gravity, which is shown by G. So we just simply say gravity, which is actually, in fact, the correct name is the correct term to describe this is acceleration due to gravity, which we know on the Earth is 9.8 meter per second per square second. Um, so, and weight is also measured in newtons. So all types of forces, they all are measured in newtons. Sometimes um, there is a situation in which, for example, there are two types of forces, field force and contact force, can act at the same time on an object. For example, look at this gymnast, which both forces are acting upon him. One is his weight, gravitational force, mg, and the two other ones are contact forces, which are acting on his hand by those rings that he's holding. Uh, Next is a tension force. So, what a tension force is? When a force is transmitted through a cable, chain string, or something like that, that force is called tension force. So, it's a pull, it's a pulling force. Yeah, it's a pulling force. So, it means that the direction of this force is always towards outside of the body or a mass which this string is attached to. These are some examples of tension force which exist in, for example, pulleys or, for example, bridge cables, and so on. Next one, there is normal force. So, what is the normal force? Normal force is called also support force. It means that when an object is placed on another stable object, like for example a table, there is a force acting upon that object from the table, and that force is always perpendicular to the surface of the contact, always perpendicular to the surface of the contact. And normal refers to perpendicular. It means making a 90 degree angle with the contact surfaces. So, for example, when we sit on a chair, there is a normal force acting upon our body, and that is from the chair, and that is why we can sit on a chair stable and we don't pass through the chair or a table or whatever we sit on, or a book whenever we place it on a table. So there is a support force or normal force acting upon that book, and that's why the book cannot pass through the table and break it and fall down through the table. The next one is friction or frictional force. Frictional force is also another type of or another kind of contact force, and it occurs when two objects come to contact with each other. And one characteristic of this frictional force is that it always opposes motion. So whenever two objects are in motion, so the direction of frictional force acting upon the object in motion is opposite to the direction of motion. So it produces heat, the frictional force. Sometimes it is useful frictional force, but sometimes it's not useful, is like harmful. And the reason, useful examples, for example, we can just say when we walk on the ground, this walking, we are pushing the ground backward while we are moving forward. So that is because of the friction. Suppose you want to walk on a piece of ice, for example. So you see, we cannot walk properly because the friction is so small. But on the other hand, friction can be harmful or can have negative effects when it comes to engine parts of a car, for example. That's why we use oil to reduce the friction. Friction depends on two factors. One is the roughness of two surfaces, and the other one is the weight of the object. So when weight is high or is large, frictional force is large, and when two surfaces are tough, again frictional force will be high. So frictional force is directly proportional to the roughness of two surfaces, and that is shown by a coefficient which we show it by mu, or is denoted by mu. Air also and water can cause friction in submarine, for example, when an object is moving under the water, it also friction also exists there because it slows down the motion and it acts upon the object, and the direction of that force also is opposite to the direction of the motion of the object. And also a resistance is another example of frictional force. Now let's move on to balance and unbalanced forces. Let's have a look at the object or figure A. We see in this case figure A, if we want to find out sigma F, which is the sum of forces acting upon this object, if we just calculate it, is equal to 0. When sigma F is 0, we say these forces are balanced, or they cancel out each other. Therefore, they are balanced forces. But in the figure B, for example, we see these two forces acting upon the object is they are not canceling out each other. Therefore, for example, the resultant force, or the sigma F, will be something like that in this direction, which the magnitude of this will be 32 Newton, for example. Yes. And another object, case C, for example. Again, the uh, sigma f. So sigma f in case P is not equal to 0, and in case C is sigma f, we will get this force. This will be our sigma f, and which is 4 newtons, and those components, vertical components, will cancel out each other, so therefore we will be dealing with only the horizontal component or components of these two forces. So in this case also sigma f is not equal to 0, so therefore we say these forces are unbalanced forces, or this object is upon unbalanced forces, so experiencing unbalanced forces. But what will happen when an object is under or acted by unbalanced forces? What will happen? Well, there are three possible scenarios which we will be looking at here. Number one, unbalanced forces can change the speed of an object, and also they can change the direction of movement of the object, and also they can even change the shape of an object. So let's have a look at the example how unbalanced forces can, or they can change the speed or velocity of an object. So suppose this object is in motion. Okay, this object, suppose, is in motion, and the direction of motion is to the right. So this is the direction of motion. This object is moving with a constant velocity or a uniform velocity. So that's why we call it uniform motion or constant motion. And we assume there is no friction between these two surfaces. Then, all of a sudden, a force acts upon this object with a magnitude of, for example, let's say 2 newtons. Then this force can change the speed, so it will increase to the speed of this object. This object will start accelerating because sigma f here is not 0 anymore. Sigma f is equal to 2 newtons in this case. So therefore, when there is a force acting upon an object with a mass, there will be, of course, an acceleration, and that is the second law of Newton. So that's how the speed of this object will change and will start increasing. So the speed of this object will start increasing because there is an unbalanced force acting upon this object. But this case, the force is the direction of the force acting on this object is parallel to the direction. And another case, suppose the same object is in a constant motion, is moving to the right or due east with a constant velocity. So this is the direction of motion. And then all of a sudden, an unbalanced force acts on this object in the opposite direction. So let's say 2 newtons again. And in this example, we again ignore the frictional forces or any other forces acting on We just assume the force at the beginning and the object at the beginning is imbalanced and is in constant motion or in a uniform motion. Then this unbalanced force acts upon this object. In this case, again, sigma f, after this force acts on this object, is not equal to 0. Therefore, for a split of the second, the object stops and then moves to the left. So the direction will change, the direction of the motion, and also it will start again accelerating to the left or due west. So this is another possible scenario or possible outcome of unbalanced forces acting upon an object. And the last possible outcome or scenario is deformation. Deformation can occur when forces act on the object, and that is because the forces are too large and are more than they cause they go beyond the elasticity area of these objects. Therefore they go to plastic area, and then they cause deformation. And this deformation can be, like, for example, compression, tension, and twisting, for example. So these are the possible deformation that might happen upon the forces acting on a object. All right. Thank you so much for watching.